Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Discrete Mathematics. So in the previous lecture, we have started the new unit called the elementary number theory. And then we have started the divisibility, and then we discuss about the modular arithmetic, right? So what is modular arithmetic? There we discuss that A is congruent to B modulo N. What does it mean? That means that N divides A minus B. So this kind of thing we have learned. Now today's class we are going to do like some applications of this modular arithmetic. So before that, I am just asking you to write to check something. But I'm going to write it, and then you have to unlock it. Let's see. Let me check. So I'm writing something. You have to identify what I have written. Yeah, so I have written something. VOMPDL. Can you recognize it, that what I have written? And then I'll come back to the applications of modular arithmetic things. Just you can make your video pause and then you can try to identify what I have written. It's very interesting. It's a fun only. See, okay, if you have done, like make your video pause and try to think and then come back. Yeah, so what I have written, basically I have encrypted one message, right? So one word I had, I encrypted it. How? Just by shifting one alphabet. Like, actually I have written this part, unlock, right? Unlock. Now how I have done? I just shifted one letter. Now you have, right? U, then I just transferred U to V. Next letter. N, after N, it is O. Then L, then it is M. I have written in place of L, I have written on. Then O, I have written P. And then C, I have written D. And then K, I have written L. So what I basically did, I just shifted each alphabet by one. Correct? So I encrypted it. Now you can easily see that, okay, I have written this unlock, but in an encryption way. Correct? Now, these things, I have done it in a very easy encryption, but you can make it a very difficult encryption with the help of this congruence. Correct? So how to do that, I will let you know. So what basically you have to do, I will do it something that, okay, suppose you write all the alphabet by some number. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, then here it is Q, R, S, T, U, V, W, X, Y, and Z. So all alphabet I have written, and for each alphabet I am assigning corresponding a number, and I start from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So each number I have assigned a new number, right? So you can now just see that which number is corresponds to which alphabet. Now why I am doing it? In the previous example, you have seen that I just have shifted each alphabet by one more alphabet, and now I have done it, which is very easy. And once somebody have some idea, they can easily decode it. So that secret message is not that great. right? But we can make it great with the help of congruence. What? How to do it? So you assign each alphabet by this thing, and then you can shift it. Like I shifted one letter. Why not? We can shift it to like many more letters. Like you can shift it to 3 letters, right? So if you shift to 3 letter, and suppose I'm writing it as V U P C. Or okay, I'll just a second. Basically, it is not like that. I wanted to tell you that what I should make. Something will do study. So I have a word called study. Now, how you can encrypt it, and by doing 3 letters, STUDY. Correct? What we have done, what we have to do. So each alphabet you have to shift 3 letters. Right. So what basically to do now? Check where is S involved. S involved in S corresponding number for S is 18. So write down this 18. Then T, it is 19. Then U it is 20. For D it is 3, and for Y it is 24. Now you add each number by 3. So 18 plus 3. Right. So this is our P. Now I am writing it FP. FP is equal to P plus 3. Now what is P plus 3? Now 18 plus 3, which is 21. So 21 I will write. Then 19. So for 21, what is the number? It is V. Then for 19, it is 19 plus 3, 22. What is the number for 22? So this is 22. Number for 22, it is W. Then 20, 23, this number, I'm adding it at 23. Number or alphabet for 23, it is X. D, 3 plus 3, 6. 6 stands for G. And 24. Now this is a little critical thing. The 24 plus 3, it is 27. But we do not have any number alphabet which assigned 27. But now your congruent modular things will come into the picture. So 24 plus 3, it is 27. Now what you have to do? You divide this 27 by 26. Then what remainder you will get? You'll get the remainder as 1. Correct? So you'll get remainder as 1. And then what 1 stands for? 1 is representing B. So this Y will be replaced by B. Right? So this is AP, not only AP, it is AP plus 3 modulo 26. We have done. So we got that. And you see that you also have shifted the 3 letter, na? Y, and then 1, 2, 3. So Y is replaced by B. Similarly, Z. Z will be replaced by what? So what will be the number encrypted message for Z? So Z stands for 25. So P is this. Now FP is P plus 3 mod 26, right? So 25 plus 3, 28. But 28 we do not have any number, but you divide 28 by 26. What you will get? What is the remainder? Your remainder will be 2. So therefore 2 is represented by C. So for Z we will have C is the secret message. Basically we have done for all the cases 21. What is the remainder if you divide 21 by 26? The remainder is 21 itself, right? Because we know the remainder is what? That A is equal to DQ plus R, that R should be non-negative, R should be less than D. So then if you divide 21 by 26, we'll get the remainder as 21. Similarly for 22, it is remainder will get as 22 only. But if it is more than 26, then only it will create some difference, right? So this is how that you can encrypt some message and you can write that something. So therefore what we have done, the word study we have encrypted in is as VWXGB. VWXGB. Now see, we create it a little more difficult, this encryption. Now who asked you to make only 3? You could have made like 15 alphabet you can shift. Yes, we can shift easily. What will happen for that? Suppose I will do for 2 or 3. So maybe S and T. And I ask you to shift for 10 alphabet. Right. So what is the basic thing? S stands for 18 and T stands for 19. Now I am saying that FP is equal to P plus 10 mod 26. Fp is equal to P plus 10 mod 26. So then 18 will become 28 and 19 will become 29. But 28 means what? 28 means Fp is equal to P plus 10 mod 26. So once we do mod 26, this remainder will become 2. In this case, remainder will become 3. But what is the representation for 2? 2 it is D, and for 3, sorry, for 2 it is C, and for D it is for 3 it is D. So it is C and D. So S and T will be represented by C and D. See, you can, with the help of this modular thing, that P plus 10 mod 26, we have written a very strong message which is encrypted in very strongly, right? So this is called the in that encryption method. And basically, this is the applications of cryptography. What is cryptography? Cryptography is the study of secret message. Right. Then we have done that encryption. Then somebody had to decode it also, right? That part we'll discuss after some time. But before that, I will tell you all the story behind it, right? All the history of this cryptography. So cryptography is the study of secret message. One earliest uses of cryptography was by Julius Caesar. Julius Caesar. He made messages secret by shifting each letter 3 letters forward in the alphabet. Now see, we have done for 1 letter forward, 3 letter, 10 letter forward. So Julius Caesar he first started these things, and he started forwarding the letter by 3 numbers, right? 3 letters he forwarded, and sending the last 3 letter alphabet to the first three. Yes, so X, Y, Z will be replaced by A, B, and C. That's what he has done. So this is an example of encryption. And this is the process of making a message secret, right? Now what he has done, so to express the Caesar's encryption process mathematically, first replace each letter by an integer between 0 to 25 based on their position in the alphabet. Yes, that's what we have done in the beginning. That's what we have done. For each alphabet we represent by some number. Then Caesar's encryption method can be represented by the function f is from 0 to 25 to 0 to 25. So it's a bijective function basically. For each alphabet we have some, for each number we have f equal to p plus 3 mod 26. So this is a bijective function, right? That's what that means. If you divide p plus 3 by 26, whatever is the remainder, that value you have to take it as f of p. Right. So in the encrypted version of the message, the letter represented by P is represented by the number that P plus 3 mod 26. Whatever number is there, the corresponding alphabet will be represented. That's what we have done. So if that is the case, now can you quickly do that? Can you quickly do the what is the secret message using Caesar cipher? So you have to shift 3 letter, right? So SRMZ. SRMZ. So basically, you have to do you can directly do it like without using all this function p equal to p plus 3 mod 23 or not. You may not do all these things. You can do it directly, I know, because this is very easy encryption. But you should know that how this encryption method works, so that once a complicated message you want to create, that time also you should do. Right? So without doing manually, I'm just showing you the process how to do it, this encryption method. So the p value first you have to calculate, and then the fp value. Fp value is p plus 3 modulo 26. Now what is the letter represent for SRMZ? Let us see. S stands for, S is for 18, right? R means 17. SR, that means 18, 17. So I'll write 18 and 17. So this is 18, this is 17. Next is, okay, just a minute. Yeah, so 18 and 17. And what is M and Z? M stands for the number 12 and Z stands for 25, right? So 12 and 25. So I'll write down that also. So this is 12 and this is 25. Now what is p plus 3 mod 26? So 18 plus 3, 21 mod 26. It is 21 itself. So I'll write 21. 17 plus 3, it is 20. 20 mod 26, it is 20 itself. 12 plus 3, it is 15 mod 26, it is 15 itself. Then 25 plus 3, it is 28 mod 26. So 28 mod 26, it is 2. Right? So these are the corresponding number. Now what we'll do? We'll do what is the corresponding alphabet. So 21, 20. What is 21 stands for V. 20 means 20. U. So this is V, this is U. What is 15 and 2? 15 means it is this one, and 2 means it is C. So P and C. So this is P and this is C. So what we have done with the secret message for this word SRMZ, right, is VUPC according to Caesar cipher. So shifting each alphabet by 3. I hope you understand. It is easy. Yeah, so this is the one. Now, once you have the original message, you should get back to that encrypted message. You should get back to the original message, right? So how to get back the original message? Using this inverse function. F inverse of P is equal to P minus 3 modulo 26. P minus 3 mod 26. Right? So how to do it? Like what we'll do, we'll find out F inverse P is equal to P minus 3 mod 26. And we all know that the remainder is always less than the divisor, which is 26, and it is non-negative quantity. So we have to make it accordingly. Right? So if you understand the method, let us do one example. It asks that this question asks decrypt the cipher text message JUHDWOP that was encrypted using Caesar cipher. So it is shifted by 3 alphabet. So you can do it manually, I know, but I might want you to learn that how you should do it using modular arithmetic, because later you will see that you can do it even very strong encrypted method. So what are the things we have? JUHDWOB. JUHDWOB. Now, what are the corresponding number? What is J? What stands for J? What U? JUH. We'll do it. What is J? J means, so it is, if the question was JUHDWOB. JUHDWOB. Now, what stands for J? J means 9. U means 20. H means 7. D means 3. W means 22. O means 14. And B means it is 1. So the numbers are 927. 927. So I'll write down there 927. 927. Again go back. And then 322, 14, 1. 322, 14, 1. 322, 14 and 1. Right? So this is your P. Now how to get back the original number? It is F inverse of P. You have to calculate F inverse of P, which is P minus 3 modulo 26. P minus 3 modulo 26. This method. Now P minus 3. So if your P is 9, what is P minus 3 mod 26? It is 6. What about this one? It is 17. What about this one? 7 minus 3, it is 4. Now 3 minus 3, it is 0. 22 minus 3, it is 19. 14 minus 3, it is 11. 1 minus 3, it is minus 2. But minus 3 cannot be a remainder. Minus 2 mod 26. That you should not have minus 2, because remainder cannot be negative. But it should be less than 26. So minus 2, if we do the remainder, it will basically gives you that minus 2 you have divided by 26. So you should get a positive remainder. What you will do? So 26 into, what you will do? It is 26 into minus 1 you do, then plus 24. Right? So then the quotient will become minus 1 and remainder will become 24. So 1 will be represented by 24. Right? So these are the numbers 6, 17, 4, 0, 19, 11 and 24. Right? 6, 17, 4, 0, 19, 11 and 24. Now again go back to the this series. I have that 6, 17, 4, 0, 19, 11 and 24. Now you check what should be the original message then. So 6 stands for G, 17 means it is R, 4 stands for E, GRE. 0 stand for A. 19 means it is T. 11 means it is L, and 24 means it is Y. So the secret message will become greatly, Greatly, right? So Gretly. So the actual message is Gretly. So this is the original message, whose secret message is this one. I hope you understand. So what we have learned using this encryption method, like we can make some message secret, and what help we have taken? We have taken the modular arithmetic, taken the help of modular arithmetic, right? So this is how you should do it. So this one is the final answer that we have already discussed. Now, as I mentioned that you can shift it to like why only 3, why only 1? You can shift it to 10 letters, you can shift it to 11 letters, you can shift, even you can shift for each alphabet by 20 letters, 22 letters, right? So that it will be in Akeda, it will be very difficult to understand that what somebody has written. But if you do it, you want to do it manually, it will be like you, there are a lot of chances are there that you will do mistake. So you should take the help of this modular arithmetic, right? So this one, that there are various ways to generalize the Caesar cipher. Like Caesar cipher is only for shifting 3. So you can generalize it. For example, instead of shifting the numerical equivalent by letter 3, we can shift the numerical equivalent to the letter K. So P plus K, that K can be any number between 0 to 25. Right? P plus K mod 26. Such a cipher is called a shift cipher. Such a cipher is called a shift cipher. And then you have to get back the original one. The same thing, that F inverse P will become P minus K mod 26. P minus K mod 26. Right? So you can easily do that. Now you have, suppose, a number between this one, GOOGLE. Now the question asks that encrypt the plain text message Google using the shift cipher with a shift of K equal to 11. Right? So then what is your P? You have to write this. What is your FP? Your FP is P plus 11 mod 26. P plus 11 mod 26. So what is that? Just a minute. Yeah, so P plus 11 mod 20. So what is P? Now G, if you look at that list, G was 17. G was represented by 6. Sorry, G was represented by 6. O was represented by 14. Again O 14. Then again G 6. L was represented by 11. And E was represented by 4. Right? These were the number. So you can check the list. And then FP equal to P plus 11 mod 26. Now 6 will replace by 6 plus 11 mod 26, which is 17. 14 plus 11, it is 25. Plus again 25. 6 plus 11, 17. 11 plus 11, 22. 4 plus 11, 15. So here all of them are straightforward keys. Right? So you, if it is more than, if this sum is more than this, you have to take the remainder. But if it is no more than 26, you should take the number as remainder. Then you can also see that 17 was represented by R Z Z. 17 is again R. Then 22 was W. Then 15 was P. So this is the secret message. If you shift the letter by using the shift cipher, K equal to 11. Right? So according the same way, like if you have something called maybe that X and Y. What is the number for X? So if you remember, X was Y was YZ, right? Y was 24 and X was 23. Correct? Now if you, what is the, according to the same shift, what is the number? P plus 11. So 23 plus 11, it is 34. 34 mod 26. What is the reminder? 34 mod 26. That means the, what is the remainder if you divide 34 by 26? What is that? This is 8. Then 24 plus 11, 35 mod 26. So this will become 9. Now what is that alphabet represented by 8? 8 and 9. So let me show you again. 8 and 9 was 8 was for I and J. So 8 and 9 stands for I and J. So in this case, I will have this is I and this is J. So using shift cipher by taking shift AK is equal to 11, our secret message for X and Y will become I and J. I hope it is clear. The similarly, how to get back the original one, like just do the same thing, that F inverse P is equal to P minus 11 mod 26. P minus 11. So what is for the number R? R is 17. 17 minus 11. It is 16 mod 26. 17 minus 6 mod 26 means it is G. So again it is G. So 6. Same way. So what is the number for 8? So I is the secret message, how to get back the original one. So I is 8, if P is 8, so F inverse P is 8 minus 3 mod 26. So minus 3 mod 26. Minus 3 mod 26 is what? So I have minus 3 modulo 26. What is this value? So the minus, so we all know remainder should be non-negative and it should be less than 35 or 26. So remainder will become minus 3. You can write it as 26 into minus 1 plus 23, right? So then the corresponding number is 23, but 23 stands for X. So I is actually original message X. I hope you understand all these things. So how to encrypt it, how to decrypt it using scissor cipher or any shift cipher. So this is the complete answer for the word Google. Now, although you have shifted for 11 letter and all, but still your message is not that greatly encrypted. But you can even make the message more strong. You know how? So instead of just shifting the letter by p plus a, like p plus k, you can represent that ap is equal to ap plus b mod 26. Ap plus b. So you introduce another two number a and b, right? But only thing is that you have to choose a and b in such a way, the integer you have to choose in such a way such that f is still a bijection, because if bijection is the necessary thing. Otherwise you will not get that. For in one single alphabet, if you get two representation number, that will create like confusion. So you have to, it is necessary that f should be a bijection. But how to make this f to be a bijection, how to make this function to be bijection? If you have GCD of a and 26, if you have GCD of a and 26 is 1, this function fp is equal to ap plus b. Ap plus b mod 26 is always a bijective function if you have GCD of a comma 26 is equal to 1. Correct? So this kind of cipher we called it as affine cipher. This is an affine transformation and the resulting cipher is called a affine cipher. Right? So what can we take? Suppose what we'll take, I can take the fp function as like 3p plus 3p plus 5. I can take in this number. Why? I can take easily this number because this GCD of 3 and 26, GCD of 3 comma 26 is 1. So this will gives you a bijective function always, right? So I can take fp is equal to, maybe I can take it as 6, 7, 8, 9. Yeah, 9p plus 3. I can take that one also. Why? Because GCD of 9 comma 26 is 1. So whenever your GCD between a and 26 is 1, this function will always become a bijective function, and this transformation will work, right? So you should be clear about it. And how to get back the original message from this inverse, that is not there in the syllabus. So you can just, if you are more interested how to get back the original one, how to find the f inverse using this one, you just search it in the internet, you will get it. So I'm not discussing that much, only I have this much, so I'm discussing this. Now, if we have understand that, you just check this one, what letter replaces the letter k when the function fp is equal to 7p plus 3 mod 26 is used for encryption, right? So I have the letter k. Now, what is the original number for k? Original number for k was k for 10, right? So original number for k is 10. So this p is 10. Now, what is fp? Your fp is equal to 7p plus 3 mod 26. What is 7p? So 10 into 7, 70 plus 3. So it is 73 mod 26. This number is coming as 73 mod 26. 73 mod 26 means what? If you divide 73 by 26, whatever is the remainder, you have to write that. Right? So if you divide 73 by 26, you will get the remainder as 21. Because 73 you can write it as 2. Because you can write 73 as a 26 into 2 plus 21. So remainder is 21. So this is the number 21. Now what is the actual number represented by 21? Alphabet represented by 21? It was V. Right? So V is the alphabet. If you encrypt by K by this, so by FP equal to 7P plus 3 mod 26, that means the affine cipher, your encrypted alphabet will be V. I hope this is clear. In this way, you can encrypt a very strong message. Right? So you have a secret message that you have encrypted in a very strongly. I hope you understand. I hope you understand the now this kind of thing you cannot do it manually also, right? Because it's a very strong message. You cannot check it and you cannot identify by looking at the secret message that what is the original message. Very strong one. And to do that manually also you cannot do. So you have to take the help of this modular arithmetic, right? So this is how this modular arithmetic is very secret, very, very significant, right? I hope you enjoyed this video. I hope that these things like motivate you to learn the modular arithmetic, and later on you will see that one cryptography course is there that you may take it in later as an open elective and all. There you'll see that a lot of applications of number theory are there, right? I hope you enjoyed the video. All the content I have taken from this book only, and we'll come up with the next video in the next lecture. Thank you very much. Bye bye.